So for this first one, it says plus sign, which means you're going to combine your like terms. So you're going to add together the terms that are alike. So your numbers without a variable, so the 2 and the 5, which is 7. And then negative 3 plus 1 is negative 2x. Now you can also switch this around and say negative 2x plus 7. So this is the exact same thing. For number 2, though, it has a minus sign, which means you're subtracting. So whenever I see a subtraction sign, I like to rewrite it as addition. So I'm going to distribute that negative and write it as 7 minus 3x and then plus everything that had that negative, everything that came after the negative, we're going to change the sign. So you see how that's a positive 6? It would change to a negative 6. And the positive 4x would change to a negative 4x. So you go ahead and you just combine your like terms. So that would be the 7 and the negative 6. And the negative 3x and the negative 4x. So go ahead and do that. So that would be a 1. 7 plus negative 6 is 1. And negative 3x minus 4x. What's negative 3x plus a negative 4x? What'd you say? Negative 7. Good job. Negative 7x. Again, you can also reverse that and write it as negative 7x plus 1. All right, now the last one, number 3, is not addition or subtraction, it's multiplication. And how do I know it's multiplication? Because it doesn't, you see how it doesn't have any operation in between? So that's multiplication. So for number 3, we're actually going to make a box. And I'm going to do it at the top of the screen so everyone can see it. Make your box. And let's multiply 2 minus 3x. Let me make that a little smaller. Hold on. All right, so we have 2 minus 3x and 5 plus x. And let's go ahead and multiply. So this is number 3. I'm just doing it at the top. So we got to take 2 times 5, which is 10. Negative 3x times 5 is negative 15x. 2 times x is 2x. And then negative 3x times x would be negative 3x squared. So now we're going to take it out, starting with the highest exponent, which would be negative 3x squared. Now these are like terms, so we can add these together. And when you add them together, that would be negative 13x and then plus 10. And that would be your final answer to number 3. Go ahead, take out your reveal books and go to page 162. All right, so remember from yesterday, we talked about simplifying before you multiply. So let's go ahead. Before you multiply, you have to remove the negative. So I'm going to take this negative 16 and break it down to negative 1 times 16. And then I'm going to take that negative 25 and break that down to negative 1 times positive 25. That's your first step. So rule number 1 that we talked about yesterday, the square root of negative 1 is what? I. So this is going to change to an I. Now 16 is actually a perfect square. It's actually one of those numbers in that box that we have on our board, our list of our first of perfect squares. What is the square root of 16? 4. So the square root of negative 16 is 4i. I'm going to actually rewrite that. So that's negative 16 is equal to, the square root of negative 16 is 4i. So what do you think the square root of negative 25 is? 5i. Good job. So now you're ready to multiply those two together. So take 4i times 5i, and that's going to give you 20i squared. Which is another rule. I squared is what? Negative 1. So we have 20 times negative 1, and my final answer would be negative 20. That is a test question. Okay. So now let's solve some equations. Let's look at example 3. Still on page 162, we're going to solve for x. So I'm just working it out. Feel free to fill in the blanks along the way or just rework it out off to the side. But the first thing I would do to solve for x is what? What do you think my first step is going to be? Subtract 81. So when you subtract the 81, you get x squared equals negative 81. Now the opposite of a square is a square root. So you have x equals the square root of negative 81. Now again, anytime there's a negative underneath a square root, you have to take it out. You cannot leave a negative underneath a square root. So x is going to equal, so the square root of negative 1 is, I. And 81 actually is the number in our box. What is the square root of 81? 9. Now, whenever you're solving an equation, though, you have to add that plus or minus in front. So your answer would be x equals plus or minus 9i. All right, let's do that check right below it. I think there's a check. Yeah, let's go ahead and do that check. So it says 3x solve 3x squared plus 27 equals 0. Let's go ahead and solve that out. Does everyone see that question? All right. It's right below example 3. So my first step to solve for x would be to do what? Subtract 27. Now you need to get rid of the 3. So we're going to divide both sides by 3. And then the last thing you're going to do to get rid of that the square is take the square root. So x equals the square root of -9. So you have a negative under a square root. So what do you do when there's a negative under the square root? You have to take it out. So the square root of -1 is I. The square root of 9 is what? So my answer is, you always put a plus or minus, and then that's why there's 2 blanks. So for one blank, you would put x equals 3i, and the second one, x equals -3i. All right, so now we're going to do operations with complex numbers, and then we'll start our homework. Okay. So looking at our complex numbers is anytime you add a real number to an imaginary number. The real part is called A, the imaginary part is called B. So let's go to example 5 on page 164, and this is just like the bell work. It's no different from the bell work. Because it's subtraction, the first thing you want to do is eliminate the negative. That's how I do it. So I like to distribute that negative, which is going to give me 8 plus 3i. And then I'm going to write that as a plus sign, and then that becomes a -4 plus 10i. Go ahead and combine your like terms to get your final answer. So when we add our real numbers together, that would be the 8 and the -4. That would be 4. And then you add your imaginary numbers together, 3i plus 10i, and what do you get? 13i, and that would be your final answer. So on page 164, you would just fill in the blank, 4 plus 13i. Try to do the check by yourself right below it. Try to do that check. All right, anybody get an answer that they want to share? What'd you get, Chris? Who got, so -2 and -3i? Anybody else get that? All right, let's work through it together. So again, the first step would be to distribute the negative. So I like to change, when I distribute that, this becomes a plus, and then both of these signs will change. So this becomes a +3, and this becomes a -8i. So when we combine our real numbers, so that would be these two, -5 plus 3 is -2. And then we combine our imaginary, 5i and -8i. 5i and -8i would be -3i. So if you had that, you are correct. All right, our last two examples are not in the book. So on page 164, you have a lot of space off to the side, or if you want to, you can pull out a sheet of paper. We're going to practice multiplying imaginary. So feel free to take out a sheet of paper, or you can write these questions off to the side on page 164. Okay, so this is multiplication. So I know for multiplication, we're kind of used to these. This is our last two examples, and then we're going to start our homework. So we're going to make our box, and we're going to multiply this out. Okay, so what goes in this first box? 5 times 3 is 15. Good. 5 times -6i. -30i. 3 times I. Okay, so now this box here, this is the box that I'm going to write off to the side, because this is where our second rule comes into play. So I'm going to do the work outside. So we have -6i times I, which is going to be -6i squared. And what does I squared equal? So what we really have in that box is -6 times -1. So in this last box is a +6. So when you combine your like terms, we start with the real numbers first. So that would be 15 and 6. 15 plus 6 is 21. And now we're going to add our imaginaries, which would be 3i and -30i. So -30 plus 3, -27i. That would be your final answer. Try to do this second example by yourself. I'm making that box so big? Okay. All right, let's go ahead and fill in our boxes. So we have 2 times 2, which is 4. 2 times 3i, 6i. 2 times negative 3i. Okay, so now we're at this last box, which I'm going to do to the outside. So 3i times negative 3i would be a negative 9i squared. I squared, though, is negative 1. So what we really have in this fourth box is negative 9 times negative 1, which is a positive 9. So now we're ready to combine our like terms, starting with our real numbers. So that would be 4 plus 9. 4 plus 9 is 13. Now, these two, when you add, you get 0. So you could just say the answer is 13. That's a perfectly good answer. You could also say 13 plus 0i. I would take either one of those answers for full credit. So let's start homework 17. Let's take out a sheet of paper. Go ahead and copy it down. Also, again, I want to emphasize you have to show your work to get credit. So take out a sheet of paper, go to page 165, and let's write down number 2. Okay, there's no graphing in this homework. Don't need graph paper. Straightforward. Let's look at number 2. Also notice that your book tells you what examples to go back to if you don't remember how to do something. So number 2 says the square root of negative 63. What is your first step whenever you see a negative underneath the square root? Take out the negative. So when I say show work, this is what I'm saying. I need to see the steps. I don't want just the answer. I need you to show me how you got to that answer. So this is the first thing I should see. The second thing I should see is you have in this box a list of perfect squares. Don't say it out loud. If you know the number, then you need to figure out which one of these numbers will go into 63. Maybe you want to write these numbers down the side of your homework because you're going to use these perfect squares a lot for homework 17. So what's the perfect square that goes in 63? 3 is not in that box. 9. 9 times what is 63? So this is what I need to see on your paper. So now we're ready to simplify it. The square root of negative 1 is I. The square root of 9, what's the square root of 9? 3. That usually goes in front of the I. And then the 7 has to stay under the square root. So if you just give me this as your answer without showing me how you arrived to that answer, you will not get credit. I just want to make sure I understand, because I know that if you take a picture, it's going to show you this answer. But I need to know that you know how to get there, because your next test is in 2 weeks. All right, try to do number 4 by yourself. So let's look at question 9. Number 9, we have to multiply 2 square roots that have negatives under it. So let's work through question number 9. Yes, the answer to all of the odds are in the back of the book. But what do you have to do? You have to show your work. So your first step is going to be to break apart that -5 to -1 times 5. And then break apart the -10 to -1 times 10. That's your first step for question 9. So the square root of -1 is I. We can't do anything with that 5. So there isn't a number in this box that I can divide into 5. So I'm just going to leave that as the square root of 5. And then this becomes an I and a root 10. So now you're ready to multiply I times I, which is I squared, and 5 times 10, which is root 50. So apart, they couldn't be simplified. 5 times 5 couldn't be simplified, and 10 couldn't be simplified. But after you multiply them, now we can. So don't say it out loud, but see if you can figure out what number in the box can go into 50. What's the perfect square that goes into 50? So we're going to break that apart. Let me go ahead and write at the top of the screen. So we have the I squared times 50, which is going to break apart to 25 times what? 2. See all this work I'm showing here to get to this answer? So now we have I squared, and that's our second rule. I squared is -1. The square root of 25 is just 5. The 2 has to stay underneath the square root. My final answer would be -5 root 2. Okay, looking at 13 and 15 and 18, I want you to do those on your own, but I want you to look at example 3 on how to do that. And then when you get down to the bottom, let's look at number 25. For number 25, just write, you just have to add your like terms. So there's really no work to show for 25. 25 is just addition. 26 is subtraction. So you have to distribute first and then combine your like terms. 31 and 32, you have to multiply, which means you need to make a box. You still have 6 minutes. Continue working on homework 17.